Hi, Driven. How are you?
Hi, Dravin.
Okay, so before I start, okay, so any questions for me for this office hours?
Yeah, I did have a couple.
Yeah, go ahead.
Work has been super busy, so I'm still working on module one. But I'm gonna try to get them both done by the end of this week. But here, I'll share my screen really quick. So I'm working on the ERC-20 with sanctions, and the issue I'm running into is that when I call the mint function in the constructor, it calls this update function, like the mint, the mint internal function calls this other update function. And I did this override to check if the wallet was blacklisted or not. But then I have to call, this or I have to call the original update function, in the parent contract. But when I do this, it causes the contract to revert and error out because the mint function the mint function in the constructor required like a balance to like allow the sending to happen. So I don't know. I was just wondering if you knew of a way to like give myself or give like the deployer wallet a big portion of the supply when I like within the constructor
Right.
without having to call that mint function, or if there's like a different way to check this logic so that it doesn't make me have to call the update function.
No update will be called, but what you are saying is from and to it should work if you do mint from the constructor.
Here, I'll show you. Let me see if I can put it in here.
Prevent constructor.
If I do, here, let me just deploy it again. I was getting a error where it just wouldn't even allow me to deploy the smart contract. I think it was like, yeah, see, it's like infinite gas in the constructor.
Sorry, what are you passing? Can you expand it? Expand it.
Which,
The deploy. Can you see the deploy button? Just expand it.
oh yeah.
Okay, now supply. Okay. We don't need comma there. Initial owner. Okay.
That's
Okay. What happens when you deploy? Deployed.
it.
Check the balance of
Oh, it worked.
initial owner. Yeah, it should work. You might be doing something
Okay,
wrong.
yeah. I think maybe I was typing it with a comma or something
Yeah. So
before.
check the balance of
Yeah.
your account, and it should show you the balance.
Okay. Okay. Cool. Wow. All right. Well, I'm happy that's working now. Yeah. And I guess I mistyped something within the initial constructor variables.
Maybe.
Okay.
All right. Yeah. What else?
I mean, that was the main question I had so far. I think I had a couple other in my notes. Let me see if I can take a look. But what did you think about the logic that I used for that? Do you think that's correct or
Yeah, that's fine.
okay?
Anybody else has any questions to ask, or is it just say Jake, Fabrizio, Sebastian?
No, not for me.
Yeah, all good my side as well.
Okay. Okay. I just wanted to keep you busy until I fix Jake's issue. I would just ask you to clone this repo and just follow the README, and then just see if you can run it. We're gonna do a code walkthrough. I want you to, just go to the steps, right? And yeah, just run this, guys. Run this command. If you are stuck, don't worry. Try to unstuck yourself on your own. If you are unable to run it, that's fine as well. But yeah,
Okay.
just go over it in the meantime. I don't want you to just sit idle. So
Yeah, I think I'm actually okay on questions so far. That was just what was holding me up.
all right. So the task for you is also the same. Spend some time. Just spend 5-7 minutes and clone the repo which I have sent.
Cool.
And try to play around with it. Yeah, just spend some time, 7-ish minutes, and we're gonna do a code walkthrough so that you know what we're talking about, right? So yeah, just go over it, and we'll resume in like 7-ish minutes, I guess. All right. So if you are running the bundler and if you had any issues, so you can check out my last week's office hours where I did demo for the same. So what I'm gonna do today is I'm going to do a code walkthrough. Did anybody is struggling to understand what this bundler is all about?
Personally, I can't run it. It gives me some errors.
Okay, if you are unable to run it, I did a live demo and it is recorded.
Okay.
So just check out previous week's office hours recording.
Okay. Thank you.
Okay.
Where can you find those recordings?
Yes, I will. So you can actually get those from Emmet. But I will see if I have the link handy with me.
Cool.
So the link which I'm pinging you right now, just bookmark it because all the office hours since the beginning are here. But some of the titles of the recordings are generated by AI, so
I see.
might be a bit confusing. For example, DAX and borrowing functionality, it is actually a decentralized exchange. Okay. Yeah, I mean, the
Cool.
interpreter just predicted it as DAX. Anyway, so these are all the liquid staking protocol. We have talked about lending and borrowing protocol. We have also talked about exchange protocol like Uniswap v2. So in here we are talking about interest accrual, borrowing, and how everything works. So it's all there. Okay, and the last office hours happened on July 26th. So it's everything about the bundler demo showcasing gas less transactions, etc. So we did that. Okay, so check out July 26th office hours and might be able to get all your questions answered. Anyway,
Sounds good.
Yeah, so the problem that Ethereum has is if you have USDC and if you would like to transfer USDC from one account to another account, you need gas, right? Do you guys know what mempools are? No? Yeah.
It's like
Yeah.
where multiple transactions get together and then they are ordered by the miners, something like that.
Exactly. So this basically bundler is an alternate to mempool. It is a private mempool. You can just take it that way. Okay. So
Okay.
so basically what it does is it's a mempool, but it is tweaked a bit. So what can happen if Jake is running his own company, Fabrizio has his own company, Sebastian has his own company. If you are having your own companies, you will have to do payroll for your employees, right? Now if there are 10 employees and all the employees are getting paid some amount in USDC, then Jake will have to make 10 transactions, Fabrizio, Sebastian, you all guys have to make 10 transactions, and on the top of that you all will have to have gas as well on the top of USDC, right? So how about we have a service which is going to take all of your transactions, bundle it together, and then broadcast it to the chain as a single transaction. How if we do that? So this is what bundler can help you to achieve, right? So of course, I mean, gas will be paid, but you won't be the one who is going to pay for the gas, right? It will be paid by some other provider and some other entity, and that entity will be of course getting fees. But what they'll do is if you are transferring USDC, then they will be charging fees in USDC basically. So you don't need gas, you don't have to make, if you have gas you don't have to make multiple transactions. Just sign it. It's like signing 10 checks and then going to the bank and then getting it settled at the same time, right? So basically you are just enabling the cashier to process like all of your checks in bulk in batch, and what difference it makes when you do batch processing versus single processing, right? Batch processing is very economical in long run. Of course you need to have that much amount of volume for that, definitely. But I mean, of course, if you had to do just one transaction, then this is not economically viable, which is nonetheless so to say. Okay.
Would you pay the fee out of the USDC that you're sending, or when you say they collect
Yeah,
a fee?
it depends on the system. So this is like a private mempool. So it is a combination of on-chain as well as off-chain code, right? So the on-chain code is this. If you go to contracts, so this is an on-chain code, and off-chain means you need a server to run. So if you go to packages, bundler, so this is a server. Yeah, this is a server which runs. So you need to run the server using yarn run bundler. So the on-chain smart contracts are there, and pages/bundler. Yeah, so it basically runs up this guy exe.ts, right? So bundler is like an RPC server, and then there are smart. If I can just go over some, I have covered it. I've covered the theoretical part, but I can take you to Vitalik's blogs. If you want to get alpha knowledge on in this space, Vitalik's blog at the so this is what it is. See, so if I can just grab pen. So the bundler is responsible for doing all of these things. Okay, yeah. So all of this, actually not, users are not the part, right? So this, right? So it will have a in memory set of pending transactions. These are not the canonical pending transactions. These are the pending transactions with respect to the private mempool, and we call it as user operations. So I told you that Jake is one user, right? Then Sebastian is another user, Fabrizio is another user, I am another user. So we all can just make a post request to this alt mempool, which is spinned up using the command like yarn run bundler, and it will receive the user operations. User operations are like bundled together, and then they are broadcasted to Ethereum blockchain. So the first command of Docker run that you saw in the README is going to spin up this blockchain. Of course, it will not be connected to the mainnet. Everything, the setup which is there in the README is all about doing it locally. But then if you can just deploy the contracts on any testnet or mainnet, you can also spin up a service, right? So yeah, the smart contracts are deployed, and that is here. Okay, so if you can just take a look here, clear everything. So these are the smart contracts. So of course, I mean, if you want to make any transaction happening, you need a gas, right? So somebody will be paying the gas. So that is done by the bundler's account. So bundler will be having its own account. Of course, it will have also a private key to it. And then there is an entry point contract where all the user operations will be passed to a function in a smart contract called handle ops. And then it is going to verify and make sure that the paymaster contract will be able to pay. And then it will call the execute operation. So all your user operations will be executed, right? So basically, what another peculiarity that you can deduce is Jake, Sebastian, Fabrizio, and myself, if we want to make a batch of transactions, we don't need to trust each other. Okay. Because whatever site signature that we are going to do for making the user operation cannot be tampered, and if it is tampered, that signature will become invalid. So the security towards your funds will have like no problem at all, right? Funds will be secure, because if the signature is tweaked, nothing can happen, right? So yeah, so that's basically.
So another question is, when you say user operation, what would be an example? Is it like, are we sending signed transactions, or
user operation is that's a good question. EIP 4337. User operation is actually a JSON object, just like a canonical transaction. User operation is also an object, but it is not native to chain. It is native to the bundler, right? So user operation has all these fields, sender, Okay. And if you talk about canonical transaction, has got, this is our canonical transaction, right? So there is a data field as well. Where is the data field? Yeah, so the data field is missing. It is optional in canonical transaction, but the serialized version of the user operation that you can see here, okay, serialized version of this JSON object will be the value of the data field of this transaction. Okay. Data is optional, so in this example they haven't shown us, but let me see if I can get you an example. Anyway, I like all these things you will be studying in upcoming modules, but if you have asked me the question, I should answer it. So the typed transaction is here. See, nonce gas price, gas limit to value data. This is a transaction which, this is a native transaction type. Okay. And the one which is this guy is the transaction type which the bundler will accept. So it has got some more data about over it. Okay. But ultimately the transaction type which the chain understands is this nonce gas price, gas limit to value data VRS. So your question next might be that how are we going to pass the JSON object of this guy, user ops, to the chain, right? So ultimately this is the one, and we will be serializing that user operation type and assigning it to this data field. Okay, so you will be able to learn more about it in module 11, where you will be building a wallet like from the scratch, like a front, just like a MetaMask. Okay, so you will be able to learn more. So I mean, did you guys understood like a bit about it?
Yeah. The idea, yes.
Yeah, it's like so the way that best way to understand is, let's talk about passing the messages when there were when there was no email, no internet. How the people used to send messages, greetings, etc. You used to do it in envelope. You need to have the recipient's name, address, and then you would have to also mention the right, I mean the greetings which you want to pass, right? So that's the data field. Then if you are sending like the first letter, then just have nonce to be 0. Gas price and gas limit, the stamp which you will have to paste it, right? You know what stamp is that you guys paste on the envelope? It's a fee, right? So you will have to purchase a stamp depending on how far you are sending the greeting letter. You will have to paste the stamp accordingly, right? Anybody who does not understand what stamp is?
No, all good.
Yeah, so that is represented as gas price and gas limit. So basically you are setting a limit on how more you are willing to spend for sending a message, right? Whom you are sending to. Okay, are you sending any money with that? Are you sending any message with that? And then your signature. So signature is represented by VRNS. So if you're doing a money order, then the value field will be having a non-zero value, right? Which means value and data are optional. Okay, you might send a message with some greetings, or you can just send an empty envelope. That is also possible. I mean, the postal services are still going to accept them. Okay, so yeah, you can just put it that way. And then let's now say that you want to combine the gas cost, because if you will be sending individual letters, individual envelopes, then you will have to each one of you will have to by multiple stems for each of the letter that you will be sending to your employees. So if each of you have 10 employees, then you will combine, you will be altogether gonna buy 30 stems. But what about you just have to buy one stamp and that is going to do the job? That's where this bundler service comes in, and the way each one of your envelope will look like will have all these parameters. Okay, does that make sense? Like, is that analogy clear to you?
Yeah, that does make sense.
Yeah.
Okay. Nice. So yeah, so digitally how can we achieve it is just spin up a server. The server, we're gonna call it as bundler. So this is a multi-package repository. They are using Lerna for that. If you don't know Lerna, then yeah, just search it on GitHub and you will get to know what that is. But anyway, it is a part of full stack concepts. So basically, it is a utility for managing multiple packages. Anyway, what we're doing is we're running the bundler. So when you are running the bundler, it will run this guy, and it starts running this. Okay. So what it will do is it will first of all create a mnemonic file. Okay. If you asked them to create mnemonic file, is like a seed phrase from which multiple private keys will be derived. So you have asked them to create one, they will create one. Like if you got a chance to go through the README, you might have found that they are just asking to run this command yarn run. Okay. But you can also pass all this commands as well. Okay, so if we are not passing it, it will not. If we are, it will create a random phrase and it is going to write it to the file. So mnemonic file, if it is not created, then it will try to create, and if it is created, then it will just throw an error because you already have the mnemonic. So program is not going to override it with a new mnemonic because that is like not safe. You might have funds attached mnemonic phrase, so which might get lost. So this is very important check we are doing. All this is happening at the time of running the bundler service. Okay. By the way, this bundler service is not for the production use. So what it's doing is it is now grabbing the config, provider, and wallet from here. Depending on the program options which we have given, we'll grab that. And another source of grabbing the configuration is the config file, which is bundler.config.json. So everything like gas factor, on which port you would like to run, on what on what address you will be able to access the chain. So our chain will be spinned up on localhost 8545. This is the entry point contract. This is the beneficiary address. Then minimum balance, max bundle gas, what minimum stake you need, unstake delay, auto bundler interval, auto bundle mempool size. So at a given point in time, how many user operations would you like to accept? So all those configurations are also read from there. Once you get the provider, we will try to know what network is, and based on the network we'll be grabbing the chain ID, because we need to make certain we have certain utility for the same, right? So program ops are passed here, and it will see if config file name exists or not. If the network is harded, then it has to be handled specially. So but the thing is, the debug trace command is not available with the hard hat network. So the recommended way is not to run a hardhead node, but to just use a Go Ethereum node for that. And then it gives us a provider instance based on the network. And it also, will read the mnemonic and also the wallet from the mnemonic, right? And it will export it along with the provider. So not only wallet, but this wallet object will also be able to make direct transactions, because now it is already connected with the provider given the network. The network that it took was from this guy, remember, right? Okay, so this basically is used for getting the chain ID. Okay, again, if it is hard hat or ganache, it needs to handled separately. So if this is a case, then we're gonna do all this stuff, but that's not something we recommend. So the reason we don't recommend is because of this debug underscore trace call. This call is not available with hard hat node. It is only available with Go Ethereum. So right. If config.conditional RPC, and if it is supports RPC method, if it does not supports RPC method, then we cannot run the bundler, right? Also, if it is not supporting the debug underscore trace call, then cannot run the bundler, because we need that. We have the utility for that, right? Next is we will have to connect contracts. Now, connection of the contracts is done, but before that we will have to deploy the contract, right? So you can see here, yarn hard hat deploy is the command, deploys the contract, right? So if you go to tips, it runs this command, learner run hard hat deploy, right? So I think might be available here. So it deploys all the command, and yeah, so it deploys the entry point contract, right? Gets the entry point address, and then what it does is deploys the entry point contract, right? So the contract shouldn't be deployed at this address. Now you might be wondering that why the address is predetermined, right? The reason it is predetermined is we are doing deterministic deployment. Okay, it is like computing the smart contract address before we deploy it, and there are certain ways through which you can do it. The way which we are using here is known as create to deployment. There's also an office hours which I did for doing deterministic deployment. The use of deterministic deployment is you can achieve same addresses on of the smart contract on different EVM chains, right? That is a use. And here you can achieve it by creating the salt. Okay, if you are using the same salt, then on different EVM chains you can get the same address, and that is how we were able to reset the entry point contract address, because we're using deterministic deployment, right? So anyway, so we're deploying the entry point, and then the second thing which we are doing is we are funding the signer. Okay, so this is the account which we are funding. Okay. So yeah, that we're doing. We are sending 1 ether, the same, right? If it had some balance previously, then we will be subtracting that balance, then we will be sending the rest, right? Because we want it to at least have 1 ether. So coming back to where we pop off is here. So now we are connecting contracts, connecting the contract, which means that it will get the entry point contract. If the entry point contract was not deployed, then it will deploy, right? If it was deployed, then it will just return the entry point contract, right? So now we will be getting this entry point contract here, and that's what we will be using it whenever any RPC call is being made. Then this is another configuration, which we call it as the execution manager config, and that is something which we are getting from here. So as the bundler config, which will have beneficiary, entry point, all those things, is essentially the config which we are passing here. Now, if you wanted to do with the Sepolia testnet, if you wanted to do with Ethereum mainnet, then all you will have to do is just replace this address, replace this URL, and you can do it, right? That's how it reads, and that's how you're gonna get this config. And this config is something we call it as execution manager config, and then it further processes the options which we have passed, right? The next process for spinning up a bundler includes initialization of the server based on the execution manager config and wallet. So this wallet, if you remember, is the bundler wallet, right? Bundler will be receiving the transaction, and that transaction needs to be bundled and broadcasted to the network. So it will definitely need to have its own account with some gas, right? So that's why we need to pass the wallet, which is also called a signer as well, because that is something which will make the transaction, the bundled transaction, right? It has got events manager, reputation manager, and mempool. Reputation is based on certain things, like how much minimum stake they have made and how much of unstake delay they have put in. So basically the reputation is more if this minimum stake is high and the unstake delay is more. That is what the reputation determines. And another reputation parameters include minimum inclusion, denominator, throttling, slack, ban slack, and all those things, right? And then we need mempool manager. If you remember, all the user operations will be held in the mempool, so we need to manage all those user ops as well. And events manager, smart contracts will be emitting the events, so we need to manage that as well. That is done by initializing the event manager on this events manager. Now we need to handler ERC-4337 transaction. So we're creating a new instance, which we call it as the method handler, and we are also creating RIP 2560, which will have execution manager and the JSON provider. And we need debug handler, and then we need to spin up the bundler server finally with the method handler, RIP 7560 method handler, debug config. This is a bundler config. This is the provider based on the network which the bundler service will be interacting. Of course, this is a bundler wallet, and it will spin up a server until you will not stop. It will keep on running. You will stop. It will create exit event. Then the bundler will stop. Right? When it stops, it will the HTTP server which it got, which it spinned up as a result of async start, will be stopped. So let's wrap up or just this thing for today, and then in the next office hours we will be talking about how this bundler processes user operation with respect to the smart contracts which you can find here. Submodules / account abstraction, that's from here. I'll give you a hint. So there is a function called handle up. This is the function from where it starts bundling the transaction. You can see that all the bundled transactions are being passed here as an array. call it as packed user operation. And if you remember, it is same as the user ops is on standard non-init code called it verification gas, paymaster and data, etc. for EIP 4337. Right, folks. So we will just keep it that much, and I hope you will have some time to go over it so that we can dive more in our next classes.
Great, thank you so much. It's very interesting.
Awesome, good to know. All right, so I hope to see you in next office hours. Till then, bye.
Thank you. Bye bye.
See ya.
Cheers, bye.